Now we look at a term called intensity of sound. Intensity of sound, that we can also call as loudness. This we can also call as loudness. This is a commonly used term, but mathematically it is a little difficult to define. Means, for example, a wave is moving like this, so that it carries some energy. Now you assume some area of cross section over here perpendicular to the propagation. That means it is just crossing through this, perpendicular to this. So I can define the intensity of sound as average energy crossing per unit area of cross section, perpendicular to its propagation, in unit time. So I can define it as the average energy. Whenever a wave is passing perpendicular to that, suppose a wave is passing in this direction, I'll just take a perpendicular area of cross section over here. How much energy is crossing per unit area of cross section in unit time? Therefore, intensity can be taken as energy per unit area per unit time, and this is the average energy. That means mathematically I can write intensity can be energy per unit time per unit area, but we have energy per unit area can be pressure. Pressure is equal to energy per unit time, energy per unit time. So average pressure can be energy per unit time. Therefore, intensity can be represented as the average pressure per unit area. So this is how also it can be defined. The first definition is going to be energy per unit area per unit time. Here, average energy by time gives rise to the average pressure. Therefore, you can also define the intensity of sound. That is what the loudness in fact can be defined as average pressure per unit area of cross section perpendicular to the propagation of the wave, and it is represented in units decibels. So units of this are decibel. Units are going to be decibel. So intensity of sound is measured in decibels. Just similar to this, there is one more term called pitch. So there is another term called pitch. Pitch is going to be a sensation. Pitch is going to be a sensation by means of which the voices of different bodies can be distinguished. A pitch is nothing but the sensation by means of which you can easily distinguish different voices. Like, so voice of a buffalo. Buffalo voice is different from human voice. And similarly, within the humans also you can have male voice is different from female voice. So on what criteria this pitch depends upon? So it depends upon the criteria that frequency. So pitch depends upon frequency. Pitch is directly proportional to frequency. That means more the frequency, more the pitch. So the frequency of female voice is more than the male voice, therefore pitch of the female is more than male. That is how you can distinguish. So pitch depends upon the frequency. So these are the two different times. The loudness is different from pitch. So loudness is energy crossing per unit area per unit time, whereas pitch is nothing but the sensation by means of which you can distinguish various voices, various sounds. Here pitch depends upon the frequency. That is how the pitch and loudness can be defined. And here one more point you need to remember: whenever a sound is produced and a human ear is sensitive to get that sound, so eardrum vibrates on receiving the sound, vibrates on receiving the sound, human on receiving the sound. So here sounds can be of various types. There are different loudness. The maximum vibration, maximum amplitude of eardrum can be 10 power minus 5 meters, and the minimum amplitude of eardrum can be 10 power minus 11 meters. So for a melodious or a sensible sound, it is vibrating for 10 power minus 11 meters, whereas for unpleasant sounds it vibrates for 10 power minus 5 meters. So this is the maximum amplitude of the eardrum and this is the minimum amplitude of the eardrum. That means whenever eardrum is sensitive to the sound that it receives, so if it's an unpleasant sound, it vibrates with the greater amplitude because of much loudness. So the vibrates with 10 power minus 5 meters, whereas detectable sound, so that can be 10 power minus 11 meters. So these are the two values you need to remember. The ratio comes out to be around 10 power 6. So this is how you can, that means the ratio between the unpleasant loudness and the pleasant loudness, it is going to be 10 power 6 times. So these are the terms which you need to remember while detecting the various sounds.